So we're looking at 5.5 here, trigonometric equations, and I've written an equation down here for us, and just like we do in class, I want you to try to solve these things as I'm working them in the video. So go ahead and I'll give you a hint here, and after I give you the hint, go ahead and try to solve this equation. And then you can hit play, hit pause the video player, solve the equation, and then hit play, and you can see how you did. So one thing to notice here is we're solving this trig equation. If we think about this as kind of a regular equation without any trig formulas in it, I think you'd have a pretty good idea how to solve this guy. So we're going to solve the trig equation very similar. So go ahead, pause your video player now and try to get that guy solved. And hit play to see how you did. Alright, let's take a look. So the first thing I want to do is get our variable terms to one side. So I'm going to subtract 3 sine of x from both sides. 2 sine of x is equal to the square root of 3. Divide both sides by 2. And so I get this then. Sine of x is equal to the square root of 3 over 2. If we think about our unit circle, where's my y coordinate? Almost the square root of 4 over 2, which is 1. It's going to be right here. That'll be one location where the sine of x is equal to the square root of 3 over 2. And another location there. So those two spots then. So x is going to have to be then pi over 3 and 2 pi over 3. Hopefully you got to that point. Now, notice in this equation here I've given you no restrictions on what x can be, which means this can go on forever. So notice this pi over 3, every time I travel around my trig circle, I'm going to hit that location again. Same with this one. So every time I go around the circle, which is 2 pi, I'm going to keep hitting these locations. So this answer will keep coming up every time I add 2 pi. And I'll put a little n on there. That's just the natural numbers, the counting numbers. So this, if n was 1, that would be adding 2 pi. If n was 2, that would be adding 4 pi, 3, 6 pi, so on and so forth. So every time that I go around the trig circle here, I'm going to keep hitting these locations. Same thing for the 2 pi over 3. I want to say, all right, plus 2 pi n, because every time I go around the circle, I'm going to hit that 2 pi over 3 as well. So one thing that I forgot to mention at the beginning of the video is that you want to have those two sheets that I sent out, the strategies for solving trig equations, and also the trig formula sheet with all the identities on it. So this problem I have up here for you is a lot like in our trig strategies, strategy number 5. So go ahead now and pause your video player and look at strategy number 5 and give this problem a shot here. Go ahead and try to solve it. You'll probably get close. You might not get it perfect, but that's okay. That's how you learn. So pause the video player, give it a shot, and then when you get done, hit play and see how you did. Alright, so we're solving this guy. So really what we're going to do is we're going to kind of think about this equation as if this was just the tangent of x equal to the square root of 3, when would that happen? Well, the two locations that the tangent of x is equal to 3, this would be at x equals pi over 3, and also at x equals 2 pi over 3. Those are kind of the locations where we would get the tangent of x equal to the square root of 3. Now if you couldn't see that, you might want to get out a unit circle here as well as you're working on these trig equations. So now the period for a tangent though is pi, so every time I hit add pi to pi over 3, I'm going to reproduce this solution again. So I'm also going to say on here plus pi n, because every time I add a pi to the tangent, it's going to start to reproduce itself. So same thing here, plus pi n. So this is kind of what I'm thinking here. If this was just solving for tangent of x, we would get these two solutions. We would get pi over 3 plus pi over n, and then 2 pi over 3 plus pi over n. Now, but we're solving for 2x, so we would want to say this then, that we want now 2x to equal this pi over 3 plus pi n. And I'd also want to say now then 2x Well, let's go ahead and solve this one first. So to solve this one, all I'm going to do is I'm going to go through and multiply by a half. So I'm going to take this equation now, multiply everything times a half, and then I'd have this. X is equal to pi over 6 plus pi over 2 times n. I can put the n to the side, or I can put it in the numerator. I think it makes more sense to just put it in the numerator like that, pi n over 2. Then my other equation here, I know that 2x, so here's one solution. Box that guy in. My other solution is going to look like this. 2x is equal to 2 pi over 3 plus pi n. And now I'm going to multiply by 1/2 here. So then I'd get x is equal to, looks like pi over 3 plus pi n over 2. And there would be my two solutions. Well, more than two solutions, but those would be the two ways I want to write all the solutions that are happening to this equation. Okay, so now we're looking at a trig equation here where we're going to solve using strategy number 1 on your sheet. Notice we have a nice quadratic here. It's set equal to 0, so what we're going to want to do is factor this. One more thing to note too is that I've got some restrictions on what the angle can be here, so this is not going to go on forever. We're only looking at solutions between 0 and 2 pi. So we're not going to have that pi n or 2 pi n on the end of our answer here, because we're only looking at one time around the unit circle. So go ahead and pause your video player now and solve this equation. When you're done, hit play to see how you did. Alright, so the first thing I'm going to want to do is factor. And so I'm going to get 2 cosine of x and a cosine of x. My last term is negative, so I'm either going to want to go minus plus or plus minus. And this one ends up being minus plus, and then 1 and 1. And notice I'm going to get the first and last pretty easy. The outsides plus insides, that'll give me a positive cosine of x. So there's the factoring. Now I want to solve each of these guys, so I would know this 2 cosine of x minus 1. Set that equal to 0. On the other side, cosine of x plus 1 equal to 0. Let's solve these guys. So over here I'd add 1 to both sides. And that's 2 cosine of x is equal to 1, divide by 2. And I'd know this then, that cosine of x is equal to 1/2. And then the other solution would occur when just minus 1 here from both sides. Cosine of x is equal to -1. Alright, well let's look at our first solution here. So when is the cosine of x equal to 1/2? Well, that happens in two locations. That's going to happen at pi over 3, and it's going to happen again at 5 pi over 3. On our unit circle here, remember my x coordinates, this is occurring when the cosine of x is almost to 0, the square root of 0 over 2, which is happening up here, which is happening right up there. Now, you might think that the answer might be happening over here, but it isn't, because that would be negative. It's an x-coordinate, would be negative. So the other place that's going to happen is right down here for an x-coordinate to almost be equal to 0. That's pi over 3 and 5 pi over 3. Alright, let's look at the other side now. Cosine of x is equal to -1. Well, if we think about our unit circle there, where is my x-coordinate going to be -1? That's only in one location. That's right there. So this is when x is going to be equal to pi. So I've got three solutions here, pi over 3, 5 pi over 3, and pi. You could just circle those like this, or you could also write those in set notation here. 5 pi over 3 and pi. Either of those answers. Now we're going to be taking our test in my math lab, so you just want to answer it depending on the way my math lab wants you to answer that question. Alright, the next question is a lot like strategy 4 on our strategy solving sheet. So go ahead and pause your video player and give this one a shot and hit play when you're done to see how you did. Notice again we've got some restrictions here on our answers. So we're just looking for answers between 0 and 2 pi. Okay, so if I'm solving this guy, I'm trying to isolate the cosine of x, so I'm going to add 3 to both sides. So I have 4 cosine squared of x is equal to 3. Divide both sides by 4. So cosine squared of x is equal to 3/4. Now this cosine squared is the same thing. That's what that means. That's squared. This is just a better notation over here to write it with cosine squared of x as opposed to cosine of x, the whole quantity squared. So to undo this, I'm going to take the square root of both sides. So I'll get cosine x on the left, and notice when I take the square root of both sides, I'm going to get plus and minus now. Square root of 3, and I think it's easier to think about these things individually when I take the square root of that. That's the square root of 3 or the square root of 4. So I'm getting two answers here. One is going to be this: cosine of x is equal to the square root of 3 over 2, and cosine of x is equal to negative the square root of 3 over 2. Alright, so now we're going to think about when does the cosine of x equal the square root of 3 over 2? Well, that's right away on our unit circle. That's at pi over 6. If we're looking at our unit circle here, remember it's when an x coordinate is almost 1. You know, at 1 here, it's the square root of 4 over 2, so it's happening right there. There I have an x coordinate of the square root of 3 over 2. The other place I have an x coordinate of the square root of 3 over 2 is right here. Again, almost going to 1. And so over here is going to be and 11 pi over 6. So I get two answers for that first one. Now we're going to take a look and figure out when the cosine of x is equal to negative the square root of 3 over 2. So we'll say this x is equal, well, right here is where it's going to be negative the square root of 3 over 2. It's going to be here on my unit circle and here on my unit circle. So pi over 6 short of a full pi there, which would be 5 pi over 6. And then 7 pi over 6. Okay, looking at our next trigonometric equation here. Notice again we're restricted to answers just between 0 and 2 pi. And so this is a lot like strategy number 2 on our strategies formula sheet, which tells us we can add and subtract trig functions to both sides, but we can't divide. So you might be really tempted to divide both sides by sine of x here to solve the trig equation. What happens is if we try to divide both sides by sine of x, we could potentially be dividing by 0, because sine of x does take on a value of 0 between 0 and 2 pi. So we're not allowed to do that because we potentially could divide by 0. And what happens if we do that is we actually eliminate some of our potential solutions. So what we want to do here is actually we want to use factoring. So we want to get everything to one side, 0 on the other, and then think about factoring to solve this equation. So go ahead and try that strategy. Get everything to one side, 0 on the other, factor. Pause your video player and try this out. And when you get done, hit play to see how you did. Okay, so as discussed, what I want to do is I want to actually subtract sine of x from both sides. Now I can't subtract sine of x from sine of x tangent x, so it's just going to look like this. Sine x tangent of x minus sine of x is equal to 0. So here we are. Now I'm trying to factor this thing, but notice they both have a common factor of sine of x, so I can factor that sine of x out front. And then it's going to be tangent of x minus 1 is equal to 0. And I'm ready now. I've got this thing factored. Now I can look at my two answers here. Well, my first answer is going to take place when sine of x is equal to 0. And on my unit circle, sine of x equals to 0 is going to happen at two locations. It's going to be at 0 and at 2 pi. According to my restrictions here, we're including both 0 and 2 pi because these are greater than or less than or equal to, sorry. All right, and then the other thing is going to happen here is I want tangent of x minus 1 to be equal to 0, which will happen when tangent of x is actually 1. And tangent of x is equal to 1 at 2 locations. That's at pi over 4 and 5 pi over 4. So our next trigonometric equation, we are going to try to factor this thing to solve, because notice we've got it set equal to 0 over here on this side. And so we would try to think about factoring, and that's what we want to do is factor. But if you look at the left side here, we won't be able to factor this thing. And the reason we can't factor it is, notice, because I have two kinds of trigonometric functions here. I got a cosine of x and I got a sine of x, and that doesn't allow me to factor this thing, at least not the way it's written right now. So our strategy here is we're going to actually use an identity. We're going to use an identity right here to make a substitution for this cosine squared of x, so that I'll have the same trig functions in this equation. So why don't you go ahead now and use one of your identities. We want to turn this cosine squared somehow into something with sine, because if we turn it into sine, then we'll be able to factor to solve this thing. So go ahead and pause your video player and try that strategy, and then hit play to see how you did. Well, from one of our trig identities, we know that cosine squared is equal to 1 minus sine squared, because if our trig identity is this, remember, sine squared plus cosine squared is equal to 1, which tells me that cosine squared is 1 minus sine squared. So I'm going to make a substitution here, and I'm going to replace that cosine squared with 1 minus sine squared of x. All right, let's take a look now. Now if I distribute my 2, I'd have this 2 minus minus 2 sine squared of x plus 3 sine of x is equal to 0. Now let's get this guy organized correctly here. So it'd be negative 2 sine squared of x plus 3 sine of x plus 2 is equal to 0. Now that guy's set up so I can factor it. So one of these guys I'm going to want to have a negative 2. So 2 sine of x plus 1 and negative sine of x plus 2. That's what that guy factors into. Now once I've got that factored, I can solve each of these. So I'll say 2 sine of x plus 1 equals 0. Equals 0. All right. So here I would subtract 1 and divide by 2. So sine of x is equal to negative 1/2. And over here, I would subtract 2 and then divide by negative 1. So sine of x, let's see, I subtract 2 would be negative 2, divide by negative 1 would be positive 2. Well, okay. This isn't going to happen over here. Sine of x is never going to be equal to positive 2 because we're on our unit circle here, and we are restricted. The values of sine of x just goes between 1 and negative 1, so that's kind of outside of our range here, so that's not going to happen. So really our answers are just going to happen when sine of x is equal to negative 1/2. And if we think about our unit circle there, that's going to happen at 7 pi over 6 and 11 pi over 6. So if we looked at our unit circle here, talking about negative 1/2, so a y coordinate that is almost 1, but also a negative, so that's happening here, 7 pi over 6. And then again over here, a y coordinate that's almost 0, not 1, but almost 0. So those are my two locations where that's going to happen. Okay, so we're going to take a look at solving another trigonometric equation, and this one again is going to be factoring. But notice when I look at my trig functions, I can't factor at this point because I don't have all the same trig functions. One of my trig functions is cosine of 2x, the other is sine of x. So my strategy here now is to make a substitution, use one of my identities or formulas here to make a substitution so that I can have the same trigonometric equations. All right, and I'm giving you a hint here. This is the one we want to use. It would be hard to change sine of x into cosine, but it is pretty easy to change cosine of 2x, which is a double angle formula, into the sine of x. And if you look on your formula sheet, you will find this, that the cosine of 2x is 1 minus 2 sine squared of x. So that's where we want to make a substitution. So go ahead and pause your video player now, make that substitution, and try to solve this trigonometric equation. When you get done, hit play to see how you did. Alright, as discussed, we're going to make a substitution there. So we're replacing cosine of 2x with 1 minus 2 sine squared of x. Now I want to get this guy organized so that we got nice descending order here in my quadratic. So I'm going to say, alright, negative 2 sine squared of x plus sine of x plus 1 equals 0. Now I'm not used to usually factoring with a negative out front. This came up on a problem earlier, and so if that was tricky for you, we can make a change here and make that a positive. So what I'm allowed to do in an equation is multiply both sides by the same number. Well, if I multiply both sides of this equation by negative 1, it will give me a positive leading term here, and that's usually easy to factor. So that's what I'm going to do here this time. I'm going to multiply everything by negative 1. So that would make 2 sine squared of x positive. It's going to make this next term negative, and that 1 will become negative. And if I take 0 times negative 1, it's still going to be 0. I think this makes it a little easier to factor. So if that one was tricky for you last time with the negative out front, you can multiply both sides by negative 1 to get a leading coefficient that's positive. So let's go ahead and try to factor that guy. So 2 sine of x. Sine of x. Last term is negative, so I need a plus and a minus. Looks like I'm going to do a plus 1 here and a minus 1 there to give me that. Yep, that will work. Now I want to go ahead and solve these guys. So I'm going to say 2 sine of x plus 1 equals to 0. And then sine of x minus 1 is equal to 0. Here I would subtract 1 and divide by 2. So we're looking at sine of x equal to negative 1/2. Here I would just add 1 to both sides, so I'll have sine of x is equal to positive 1. Let's take a look at when that happens. So we're looking at just the interval 0 to 2 pi here. So when does the sine of x equal to negative 1/2? Well, that's almost at 0, so I want a y coordinate that's almost at 0 but negative. So here would be one spot, here would be one spot. So it looks like here we're going to get x is going to be 7 pi over 6 and 11 pi over 6. Alright, sine of x is equal to 1. Well, that's happening only in one spot. That's where my y coordinate is equal to 1 up there at the top of my circle. So that's going to be x is pi over 2. Okay, look at another trig equation here. I will try, so our strategy here is, we would think about factoring. But notice again, we've got just sine x and cosine of x, and that makes it really tricky to factor right now because we have both different sorts of trig equations there. So I'm trying to get this to have the same trig equations to make a substitution. However, most of my substitutions involve sine squared or cosine squared, and I don't have that here. But I can manipulate this equation so that I do have a sine squared and a cosine squared. And the way that I'm going to do that is I'm going to square both sides of this trig equation. So if you look on our strategies for solving trig equation sheet, strategy 3 says if I square both sides, I got to check the answers. Because what happens is if I use this strategy of squaring both sides, I can introduce false or extraneous solutions. So when I get done with this thing all the way in the end, I'm going to have to check it. So our strategy here is to square both sides of the equation, manipulate a little bit so we can factor. Once we get factored, we will find some answers, but then we got to check those answers back in our original trig equation. So go ahead and pause your player here and give this a shot, and when you get done, you hit play to see how you did. Alright, so as discussed, I'm going to square both sides of this equation. So I'm going to take the left side, square it, take the right side and square it. Well, the right side's easy. That's going to give us 1. The left side, I need to be careful here. This isn't going to be sine squared minus cosine squared. I got to actually multiply these two binomials out. So sine of x minus cosine of x times sine of x minus cosine of x. So that's going to give me sine squared of x, and then my middle term will be negative 2 sine of x cosine of x, and then plus cosine squared of x. Alright, now I've got this guy almost ready to factor, except the problem is I have different trig functions going on here, right? I got sine squared, I got cosine squared, and then I've got this 2 sine x cosine of x. So I don't have all the same trig functions yet. But notice I do have this. Notice if I take sine squared and cosine squared and add those together, I know that that's equal to 1. So that's what I'm going to do first here. I'm going to say, okay, 1 minus 2 sine of x cosine of x. Well, that simplified things quite a bit for me there. Now, I think also I want to have 0 over on this side if I'm going to factor. So let's go ahead and subtract 1 from both sides. So that's going to give me negative 2 sine of x cosine of x is equal to 0. Now, I'm ready to actually do this. I've got two different factors. It won't matter now that I have a sine x and a cosine of x here. So I'm going to go ahead now and say, well, when does negative 2 sine of x equal to 0? And when is cosine of x equal to 0? So really this boils down to on both sides just when it equals to 0. When does the sine x equal 0? And when does cosine of x equal 0? So sine of x equals 0 at 0 and 2 pi. Cosine of x is going to be equal to 0 at 2 locations. That's going to be pi over 2 and 3 pi over 2. So now I've got 4 potential solutions. But now I need to check to see if they work. So going back to my original equation, I need to check 0. And so let's see, sine of 0 minus cosine of 0 is supposed to be equal to negative 1. Well, let's see, sine of 0 is 0. Cosine of 0 is 1, so if I had 1 minus 1, so that checks. So that first answer checks. 2 pi, if I check 2 pi, it's going to be in the same location as 0. So I know that works. So this kind of check actually works for both 0 and 2 pi. So I would know that both of those answers would work. Since 0 and 2 pi are the same location on the unit circle, it's going to give us the same answer there. So I know those both work. Let's see pi over 2. Let's check pi over 2. So I'd say sine of pi over 2 minus cosine of pi over 2 is equal to negative 1. So let's see, sine of pi over 2, that's going to give me 1. Cosine of pi over 2 is going to give me 0. So 1 minus 0 equals negative 1. No, that's not a good solution. So we're going to nix that one from our answer set here. So we're getting rid of pi over 2. That didn't work. And let's see, 3 pi over 2. So we have sine 3 pi over 2 minus cosine 3 pi over 2 is supposed to be equal to negative 1. let's see, sine of 3 pi over 2, that is going to be -1. And cosine of 3 pi over 2 is 0. So sure enough, that one checks. That's a good solution. So it looks like we're just getting 3 solutions here. 0, 2 pi, and 3 pi over 2. When I look back on this, right when I paused it there at the end, I noticed I made a mistake. We should have had also, as a potential solution here, pi, because sine of x is equal to 0 at pi as well. I missed that one. But if we check pi, it doesn't work. So if I plug that back into the original equation, it doesn't work. So this is my solution set down here. This is 0, 2 pi, and 3 pi over 2. But I also should have checked pi. So if you got an answer of pi, and you're wondering why I didn't have that, well, you were right. You should have included that in here, but when we check it out, it doesn't work. All right, next kind of problem we're going to solve is where we're not on a nice value on our unit circle that we can look at and find. So we're going to use a calculator here to solve some of these trigonometric equations. So I've got now that the tangent of x is equal to 3.104. We're trying to solve this. We're trying to solve this here to 4 decimal places and between 0 and 2 pi. So notice we're trying to look for solutions that are 0 and 2 pi. Tangent inverse, when we use our calculator to find tangent inverse, it's going to give us solutions between -pi over 2 and pi over 2. So we might have to, in fact we're going to have to, make sure that when we use the tangent inverse, that the answers we get here between -pi over 2 and pi over 2, we have to transfer those answers back to our solution set, which is between 0 and 2 pi. Okay? We want to make sure that our calculator is in radians to do this. So go ahead now and pause your video player. What we're going to do is we're going to take the inverse tangent of this to solve. That's going to give us an answer between -2 pi and pi over 2. And we want to take that answer then and look back at our unit circle and see if we can find any solutions then on this between 0 and 2 pi. Use our answers here, look at our unit circle, and come up with these answers between 0 and 2 pi. This might be a little tricky, but give it a shot and see if you can come up with, there's 2 solutions here that we're looking for. See if you can come up with 2 solutions. When you're done, hit play and see how you did. All right, so first thing we're going to do is we're going to take the tangent inverse of both sides. And when we take the tangent inverse of this angle, it's going to tell us that the angle here is equal to, in radians, 1.2592. All right, so that's our first answer. So if we looked at our unit circle here, this guy is going to be right about here on our unit circle if we're looking at radians. So right about there. So we're getting close to pi over 2, but not quite. So that's where that location is. Now we want to look anywhere else around, going all the way around this circle one time. Remember, our answers are between 0 and 2 pi, so that's going around the circle here, one whole time, and see where else that answer is going to occur. Notice the period for the tangent is pi. So it's going to start here, go through a full cycle in the first pi. Then if I come down here, it's going to reproduce itself again and go through that same exact cycle. So one answer is happening here. The next answer is going to happen here on my unit circle. Since the period of the tangent is pi, it'll start to reproduce itself again there. Now, I want to think about, on my unit circle, how to get from this location to this location. Well, the way I do that is just add another pi to it. So my answer, my first answer, is going to be this 1.2592. My second answer is going to be that 12592 plus pi to get to this next location here. And so if I take 1.2592 and I add pi to it, it's going to give me 4.4008. And so here are my 2 solutions. One is that. My next one is that. That was supposed to be an 8 there. Okay, we're going to use a calculator again to solve another trigonometric equation. So we're going to solve this sine of x is equal to 0.2315. And notice, remember that sine of x, inverse of sine of x, is between negative pi over 2 and pi over 2. So when you use your calculator to get an answer here, what it's going to do is it's going to spit out an answer somewhere between negative pi over 2 and pi over 2, somewhere in here. And what we want to do then is we want to translate that answer back to our domain here, which is that x has to be between 0 and 2 pi. So if you ended up with an answer down here, which is what we're going to do, we're going to end up with an answer down here when we take the inverse, but we want to turn that answer, instead of a negative value, we want to turn that answer, how we would get that answer, between 0 and 2 pi. So go ahead and give this a shot, and when you get done, hit play to see how you did. Alright, so the first thing we want to do here to solve for x is we're going to take sine inverse of both sides. So we'll take sine inverse of the left, sine inverse of the right, and so really what we turn up with is here sine inverse of this negative 0.2315. And when I take the inverse of that, it's going to give me this negative angle. So negative 2.336. We wanted 4 decimal places, but that's negative. Now notice an angle measure. This is an angle measure that's negative. That does not fit in our domain here for x. X is just between 0 and 2 pi. Okay? So we're down here negative, just like I talked about. This is our location. But at this point, that's a negative location. We want to now turn that into a positive location. Notice sine is going to be negative here. This negative value. Sine is also, if we look at the full unit circle now, this location here would also be a solution to this problem. If it works here, sine, the y-coordinate here is going to be same as the y-coordinate over here. So those are the two locations I can come up with this answer. Now I want to find out how to get to these two locations. Now instead of going in a negative direction like this sine inverse has us going, I want to figure out how to get to these spots moving in a positive direction. So how would I get to this spot moving in a positive direction? Well, to get to this location, I would take, first I would go pi. That would get me to here. Then what I want to do is I want to add just this little bit of angle right there to get to that new one. Well, what's that little bit of angle? That little bit of angle is this, but a positive value, because I'm traveling this distance in a positive value now. So I'm going to take pi plus 0.2336 to get that first answer. Now, to get to the second location here, moving in a positive direction, one way I could think about this is I can go all the way around the circle. I could go all the way around here at 2 pi and then drop back this little distance here. Dropping back this little distance here. Well, what's that distance? That's that angle. So I could do 2 pi minus then this 2.336. And that's going to get me to these two answers in a positive context, because my answers are supposed to be between 0 and 2 pi, and this inverse function spit out this negative angle measure. Well, negative angle measures aren't going to work according to what I have. So what I do is I go back around here and manipulate and figure out how to get to these two locations, here and here, moving in a positive direction. So let's see, if I take pi plus this 2.336, it's going to give me 3.3752. That's one of my answers. And if I take this one, 2 pi minus that angle, that's going to get me 6.0496. Now this is a little tricky. This is one of those things, especially this part right here, where you're trying to figure out these locations on the unit circle. So I think it's a good idea to practice with a little help and support. And if you guys go in your workbooks in section 5.5, and if you go to questions 6A and 6B, you can practice 2 more of these problems. I think after you practice 2 more of these problems, you're going to get the hang of this. There are some different ways to come up with these answers than what I'm doing here on the unit circle, and I think in our workbook they use a little different strategy. So you might want to check that out and see if that works better for you. But I think after you do 2 more of these problems, you'll have the hang of this. That's it for section 5.5.